Welcome back to today's session. See, most of you have requested me to solve another problem so that you will understand the procedure of Modi method in a better way. Therefore, today I would be solving one more problem using Modi method. And few of you have asked doubts regarding degeneracy check. See, I did not discuss about degeneracy check because, anyhow, after this problem, we will be looking into degeneracy case and method of handling degeneracy case in transportation problem. That is the reason I did not check for degeneracy case. And I was also very sure that the problem that I have taken does not have a degeneracy case, right? That is the reason I have not checked degeneracy in the problems. So shall we start off? The problem that we consider for today is obtain the IBFS of the transportation problem using LCM and optimize using Modi method, whose cost matrix is given below. Because the decision variable is cost, it is minimization case. And next thing that we are supposed to do is check whether it is balanced or not. So 7 plus 3, 10, 10 plus 5, 15. So supply totals is 15. Check the demands. 4 plus 3, 7, 7 plus 4, 11, 11 plus 4, 15. So even the demand totals are 15. So because the totals match, it is a balanced problem. And the cost matrix given to us is 2, 2, 2, 1, 10, 8, 5, 4, 7, 6, 6, and 8. So this problem we are supposed to solve first for IBFS using LCM and then optimize the solution using Modi method. Okay. So since summation AI is equal to summation Bj is equal to 15, the problem is a balanced transportation problem. So because it is balanced transportation problem, straight away you can apply LCM to obtain the IBFS. So out of the cost matrix, which is the least cost is 1. So I'm supposed to make an allocation at 1, 4. How many units? Supply is 3, demand is 4. So I can transport 3 units. So supply becomes 3 minus 3, 0. Demand becomes 4 minus 3, 1. So I have an allocation at 1, 4 with 3 units. And this row, so this row is now crossed off. The remaining matrix that I have is 10, 8, 5, 4, 7, 6, 6, 8. So out of this, the minimum cost is 4. So because the minimum cost is 4, we will have to perform allocation here. Supply is 7, demand is 1. So you can transport only 1 unit. So make an allocation of 1 unit here. So in that case, supply becomes 7 minus 1, 6. Demand becomes 1 minus 1, 0. So I have an allocation at 2, 4 with 1 unit. So this row was gone already and now this column is gone. So the remaining cost matrix is 10, 8, 5, 7, 6, 6. Okay. So which is the least cost? 5. So we are supposed to make an allocation here. Demand is 4, supply is 6. How much you can transport? 4 units. So you will have to transport 4 units here. So supply becomes 6 minus 4 is equal to 2 and demand becomes 4 minus 4, 0. So in that case, I have an allocation at 2, 3 with 4 units. At 2, 3, I have an allocation of 4 units. So now this row is gone, this column and this column is gone. So the remaining matrix is 10, 8, 7, 6. So out of that, the least cost is 6. Supply is of 5 units, demand is of 3 units. So I can satisfy only 3 units. So make an allocation of 3 units at 3 comma 2, and the supply becomes 5 minus 3 2, demand becomes 3 minus 3 0. So I have an allocation at 3 comma 2 with 3 units. So this row is gone, this column is gone, this column is gone, and this column is also gone. Now I am left out with only 10 and 7. So least cost is 7. So I am supposed to make an allocation here. Supply is 2, demand is 4. So I can satisfy only 2 here. So supply becomes 2 minus 2 0. Demand becomes 4 minus 2 2. Right? So I have an allocation at 3 comma 1 with 2 units. Okay? Now this row is gone. Third row is also gone. These 3 columns are gone. Now I am left out with a single cell. So when a single cell is left out, the supply and demand would match. So I have supply as 2 units, demand as 2 units. So satisfy 2 so that the demand also becomes 0 and the supply also becomes 0. So I've got a IBFS here. So the IBFS has how many allocations? 1, 2, 3, 4, 5, 6. See, as I said, degeneracy case would not be present. See, if you have a look, I have 3 rows and 4 columns. 3 plus 4 is 7. 7 minus 1 is 6. So I have got 6 allocations. So it is still a non-degeneracy case. Okay. Calculate the TTC and have a look. So I'll get 3 into 1 plus 2 into 10 plus 4 into 5 plus 1 into 4 plus 2 into 7 plus 3 into 6. So which gives you 3 into 1 is 3, 2 into 10 is 20, 4 into 5 is 20, 1 into 4 is 4, 2 into 7 is 14, 3 into 6 is 18. So I get a total transportation cost of 79 units. So now I'll have to consider the IBFS and go ahead with optimizing, right? So I'll have to apply Modi method here. So the IBFS has been copied. So how many allocations you have? 6. If you want, you can just check for the degeneracy case. It is not a degeneracy case. Therefore, you are supposed to calculate the UI and VJ values. So because this row has 3 allocations, I put its corresponding UI as 0. Right? Based on these reference values which I have marked in red. So 10 minus 0 is 10. 5 minus 0 is 5, 4 minus 0 is 4. So I get 3 VJ values. So now I'll have to consider individual VJ values and compute corresponding UI values. So when I take this as a reference, so 7 becomes the reference value, 7 minus 10 will be minus 3. Okay. Now consider this 4 as the reference. Considering this 4 as reference, sorry, I missed out on the arrow mark. So 1 minus 4 is minus 3. Okay. Now this UI will not be of any use. This 0 has been used. This minus 3 can be used to obtain this value. So let us check it. So using this minus 3 as reference, 6 minus of minus 3 becomes 6 plus 3, 9. So VJ value is 9. So we have computed all the UI and VJ values. UI values are minus 3, 0, minus 3. VJ values are 10, 9, 5 and 4. So after computing all UI and VJ values, what are we supposed to do? In all unallocated cells, right? At 2 and at this 2, at this 2, at 8, at the 6 and at this 8, we will have to calculate the net evaluations, EIJ values. Okay, let us calculate it. So coming to this point, 2 minus of minus 3 is 5. 5 minus 10 is minus 5. So I get a minus 5 here. Consider this cell 2 minus of minus 3 is 2 plus 3, 5. 5 minus 9 is minus 4. So I get the EIJ value as minus 4. Here, 2 minus of minus 3 is 2 plus 3, 5. 5 minus 5 is 0. So the EIJ value is 0. Coming to this location, 8 minus 0 is 8. 8 minus 9 is minus 1. I get the EIJ value as minus 1 here. Coming to this position, 6 minus of minus 3 is 6 plus 3, 9. 9 minus 5 is 4. EIJ value is 4. 8 minus of minus 3 is 8 plus 3, 11. 11 minus 4 is 7. So the EIJ values are 7. So out of all the EIJ values, identify the most negative EIJ. I have 3 negatives, minus 5, minus 4 and minus 1. Out of these 3, which is the most negative? Minus 5. So I take this as the first end point or the corner point. So I am supposed to construct a loop. So from here, I get a continuation to this point. From here, I get this point. And from here, I get this point. From here, I can get back. So I am able to form a closed loop in such a way that the most negative EIJ point was one of the corners and the remaining 3 corners were allocated cells. Okay? 3 is an allocated cell, this 1 is an allocated cell, this 2 is an allocated cell. So these are acting as the 3 corners for the allocations that I am making. So in that case, theta value has to be, theta has to be assigned. So I start with plus theta. In the starting point, I put plus theta. Alternating sign here, it becomes minus theta. Alternating sign plus theta. Alternating sign becomes minus theta. So I have 2 plus thetas and 2 minus thetas here. So consider the minus theta allocations and minimum of it will be the theta value. So theta equals minimum of 2 here and 3 here. So out of 2 and 3, which is minimum? 2. So theta value is 2. So once you have calculated the theta value, wherever you have minus theta, that value has to be subtracted. So this becomes 2 minus 2, 0. So this allocation will be lost. Here I have plus theta. So there was no allocation, that means 0. So 0 plus 2 is 2. So I get an allocation of 2 here. And what about here? It is minus theta. So 3 minus 2. 3 minus 2 becomes 1. And here I had a plus theta. So 1 plus 2 becomes 3. So I get 0 here, 2 here, 1 here and 3 here. See? So I get a 2 here, 1 here, 3 here and a 0 here. So now how many allocations do I have? Once again 6. Still a non-degeneracy case. So what am I supposed to do? Calculate the UI and VJ values. So when you calculate the UI and VJ values, here also I have 2 allocations, here also I have 2 allocations, here also I have 2 allocations. So arbitrarily I can choose any. So I will choose this only. So I'll make this UI value as 0. So these 2 values becomes reference values. So 5 minus 0 will be 5. 4 minus 0 will be 4. Okay. So we have obtained 2 VJ values here. Now use these VJ values. So this VJ value cannot be used because there are no other allocations. I am supposed to use this VJ value as reference. So 4 as reference. Here I have an allocation. Therefore 1 minus 4 is equal to minus 3. So one more UI value I've got. So now I'll take this as reference and here I have one more allocation. So I will compute the next VJ value. So using this as reference, Because I have allocation here, 2 becomes the reference. 2 minus of minus 3. So 2 plus 3, 5. So I get a 5 here. Okay. Now I will use this 5 as reference and calculate this UI value. Using this 5 as reference, 7 minus 5 is equal to 2. So this UI that I have calculated now, I will take it as reference, and because I have an allocation here, I will be able to calculate the Vj value here. Okay, it will be 6 minus 2 equals 4. So now you see that all UI and Vj values are calculated. What is the next task? Suppose to calculate Eij values. So I will get a Eij value at 1, 2, 1, 3, then 2, 1, 2, 2, then 3, 3, 3, 4. Okay. So let us calculate the Eij values. Here first, 2 minus of minus 3 is 2 plus 3, 5. 5 minus 4, I get a 1. So here the Eij value is 1. Coming here, 2 minus of minus 3. So 2 plus 3, 5. 5 minus 5, 0. So I get a 1 here, I get a 0 here. Then coming here, 10 minus 0 is 10. 10 minus 5 is 5. So I get a 5 here. Then coming to this place, 8 minus 0 is 8. 8 minus 4 is 4. So I get a Eij value 4 here. So all of them are as of now positives. So coming to this value, 6 minus 2 is 4. 4 minus 5. 4 minus 5 is minus 1. So I get a negative here. Minus 1 I get. And here 8 minus 2 is 6. 6 minus 4 is 2. So only in one place I get negative. Okay. So I get 1, 0, 5, 4, minus 1 and 2. So the only negative Eij is this. So still I have not yet arrived at optimal solution. Therefore I will have to further optimize it. I am supposed to find out a closed loop. From here, if at all I take a link here, I will have to go here, but I cannot come back because I don't have an allocation here. So therefore, from here I'll go here, from here to this cell, but I have a continuation here. I'll go to this cell. From there I get a link. I come here, back here. So I start from here, then I come one step up, one step to the right, one step up, 3 steps back, then 2 steps down, and back to the starting point. Okay. So I considered this problem because I wanted to show you that closed loop need not be always a quadrilateral. So I can have a hexagon as well. A 6-point closed figure can also be there. So this is one such example. That is why I took this problem. Okay. Now from the starting point, this will be plus theta. Here alternate sign minus theta, alternate sign plus theta, alternate sign minus theta, alternate sign plus theta, alternate sign minus theta, and back to the original point. So now you observe that you have 3 plus thetas and 3 minus thetas. So all the minus theta values have to be considered so that I'll get the new theta value. So at minus theta here I have 4, at minus theta here I have 1, and at minus theta here I have 2. So I have 2, 4 and 1. The minimum of the 3 will be my new theta value. So my new theta value is 1. Okay. So here I have a plus theta. So 2 plus 1 becomes 3. So this position becomes 3. Here 1 will be subtracted. So this will become 1. So I get 3, 1. Next coming here, I didn't have an allocation. So now I am adding 1. so I get a 1 here. This 3, as I said, will not be changed because it is not a part of the loop. So I get 3, 1 and a 1 here. Then here 1 has to be subtracted. So this becomes a 3. And here 1 has to be added. So this becomes 4. And 1 has to be subtracted here. So this becomes a 0. Okay. So the new allocations that I've got are 3, 1, 3, 1, 3 and 4. Once again, if you observe, I have 6 allocations. So not a degeneracy case. Therefore, I can go about computing ui and vj values. So here, because I have 3 allocations in the same row, I will take this ui as 0. So this as 0. So these will become the reference values. Whatever I have marked in red becomes the reference values. 7 minus 0, 7. 6 minus 0, 6. 6 minus 0, 6. 3 Vj values are computed. Now consider this first Vj as a reference. So when I take this first Vj as reference, 2 becomes the reference point. So 2 minus 7 is minus 5. Okay. 2 minus 7 is minus 5. So this minus 5 cannot be used as reference because I have only one allocation here. This I have already used. This cannot be used because there is only one allocation. So I will have to use this 6, the third Vj value, as a reference now. Use it as reference. So this becomes the reference point. 5 minus 6. 5 minus 6 is minus 1. So I get a minus 1 here. Now use this minus 1 as reference. This 4 becomes the reference point. 4 minus of minus 1 is 4 plus 1, 5. So all ui and vj values are calculated. Once all ui and vj values are calculated, what are we supposed to do next? Calculate the eij values at non-allocated cells. So at 1, 2 you will get a eij. At 1, 3 you will get a eij. 1, 4 you get a eij. 2, 1, 1 eij. 2, 2 you will get one more eij. And at 3, 4 you will get one more eij. So let us calculate it. So this becomes 2 minus of minus 5. So 2 plus 5, 7. 7 minus 6 is a 1. So I get 1 here. 2 minus of minus 5 is 7. 7 minus 6, 1. So I get a 1 here. I get a 1 here as well. Then 1 minus of minus 5 is 6. 6 minus 5 is once again a 1 here. So all the 3 places I have got 1. Check here. 10 minus of minus 1 is 11. 11 minus 7. 11 minus 7 is 4. So I get a 4 here. Here 8 minus of minus 1 is 8 plus 1, 9. 9 minus 6 is a 3. So I get a 3 here. Coming to this point, 8 minus 0 is 8. 8 minus 5 is a 3. So we see that all the EIJs are positive. 1, 1, 1, 4, 3 and 3. So as all the EIJ values are positive, this is an optimal solution. And we see that none of the EIJs are 0. Therefore, the obtained solution is unique. So calculate the TTC for the problem now. So it is 3 into 2 plus 3 into 5 plus 4 into 4 plus 1 into 7 plus 3 into 6 plus 1 into 6. So 3 into 2 is 6, 3 into 5 is 15, 4 into 4 is 16, then 1 into 7 is 18, 3 into 6 is 18. 1 into 6 is 6. When you add up all these values, 6 plus 15, 21. 21 plus 16 is 37. 37 plus 7, 44. 44 plus 18, 54. 54 plus 8 is 62. 62 plus 6, 68. So the optimal TTC is 68 rupees. So if you remember, the IBFS was 79 rupees. So IBFS was 79 rupees. I have optimized it and got the best solution to be 68 rupees. Hope you have understood the working of Modi method clearly. If at all you have any doubts, you can kindly post it on the classroom platform. So thank you for your patient listening. Have a nice time. Enjoy. Thank you. Kindly be home and be safe.